All right, we're back. We're going to be on page 133, but I did say at the end of the last video that I wanted to do this problem in a slightly different way, just to show you how you could confirm your answer after you kind of like go through this process. So, I mean, if I told you to use vectors, this is pretty much the way I would kind of think that you would do it. But there is like another kind of clever way that you can do it. And it like, I'm going to use a vector, but it's not really a vector approach. All right, so you have your line, and then you have a point. And so what I'm going to do is I'm just going to create the line perpendicular, and then I will find the intersection. And then what I'm going to do when I use vectors, I'm just going to find the norm of the vector between these 2 points. So this is the point 35. This is the point 35, and then this is our line. So I'm going to use a calculator to just kind of like knock that out really quickly. So the line. So let's switch over to the calculator and see if we can do that. So this is like, I mean, this is where you're like left to your own devices, solve this however you want. So I'm going to solve the given line, y equals negative 2/3 x plus 9, and the perpendicular through the point 3/5. So that's like y minus 5 equals perpendicular slope would be positive 3/2, and then x minus 3. So that's point slope form for the perpendicular line through 3/5. And I want to solve for x and y. So I get these. So what I'm going to do is, I'm not even going to write that down. I'm just going to like use it. So I'm going to find the norm. So menu 7, enter, of xy minus 3/5. And then such that, so control equals 1 over, x is this and y is this. And I'll press enter, and you can see we get 6 root 13 over 13, which is the same answer that we got last time when we got 6 over root 13, because I de-rationalized, or I guess I rationalized the numerator. But anyway, I just wanted to show you that it's another way you can do it, and it's definitely a way, no matter what the directions are, that's a way you could check your answer for sure. So let's see what's on this page. It's just more practice. I do not anticipate any challenges until potentially like arithmetic or whatever on E and F, because gross. All right, let's see. So we want to find 3a, the magnitude of 3a and the magnitude of a. I mean, it makes more sense to find the magnitude of a first before you find the magnitude of 3a, so I might actually do that. But actually, it's 5, 12, 13, so you just like know that it's 13, but whatever. 3a, here we go, 3a. We're doing this in blue, apparently. It's going to be 15, 36. The magnitude of a, it's 5, 12, 13, so it's going to be 13, and that is the square root of 5 squared plus 12 squared. And then, therefore, the magnitude of 3a is going to be 3 times that. So 3 times 13, so 39. All right, I can already feel people saying like, slow down, what's the rush? Hit the gear, change the speed of the video, and you can watch it whatever speed you want. All right, a plus b. I don't know what we're getting out of this. A plus b, I mean, I guess it's, you know, practice. A plus b is 5 plus 7 is 12, and 12 plus 24 is 36. A minus b is 5 minus 7 is negative 2, and 12 minus 24 is negative 12. And then b minus a, so I will do something a little weird here. I'm going to say it's just the negative of a minus b. So that's going to be 212. All right, 2 unit vectors orthogonal to a, right? So a is 512. All right, so a looks kind of like, maybe like this, right? And I need 2 unit vectors that are orthogonal. So one of them kind of goes like this, and then the other one should just go in the opposite direction, right? So if I can find one, I can find the other. So what I'm going to do is I'm going to use the swap and change trick, right? So first, I'm going to say perpendicular to a. So let's call it a sub perpendicular. I don't know, what notation would I use for this? A sub something. I don't know. Let's turn A into a unit vector. A over the magnitude of A. It's like I just abandoned ship on the whole. So 5/13, 12/13. All right, so now, therefore, let's use, so swap them, 12/13, 5/13, but you also have to change the sign of one of them. So that's one of them, or you could have changed the sign of the other one. There you go. Those are two unit vectors that are orthogonal to A. And we could check like all of these. I'm going to go back and check these when, like for E and F, I think I'm just going to use a calculator to do all my calculations. I'll check these on the calculator when we get there. Angle between A and B. All right, so I know that the cosine of the angle is going to be A dot B over the magnitude of A, the magnitude of B, which means that theta is going to be the inverse cosine of A dot B over the magnitude of A, magnitude of B. So let's see what this gives us. It's the inverse cosine of A dot B. So let's up here, A dot B is going to be 35 plus, what is this? 288, I guess. So I thought of it as 12 times 12 times 2. 12 times 12 is 144, and then times 2. So this is 323. And then the magnitude of A is 13, and the magnitude of B is 25. 13, 25. Magnitude of A times the magnitude of B is 13 times 25. Which is like if you had 13 quarters. If you had 12 quarters, you'd have $3, and then another, so 325. So 323 over 325. Inverse cosine of 323 over 325. So 323 over 325 is really close to 1, which means it's really close to the inverse cosine of 1, which means the angle between them is like almost nothing. Like the inverse cosine of 0, no, sorry, the inverse cosine of 1 is 0. So this is like really close to 0, but not quite 0. And again, I will check that on the calculator, I guess. Find a pair of orthogonal vectors whose sum is A with one vector in the direction of B. All right, let's set this up so that we can do our thing, right? You always want to set it up so that it like works the way you want it to. So here, you have to sum up to A. So this will be A. And then one of them is parallel to B, or in the direction of B. So I'm going to say this is B. So I'm looking to find, I'm going to call them U and V. So I'm looking to find U and then V. All right, so what do we know? We know if this is theta, cosine of theta is going to be, all right, so we already know A and B. A dot B, magnitude of A, magnitude of B. This might not actually be that bad by hand, but I'm still not going to do it. Then by the right, so this was using the vectors that we know. Now we're going to use the right triangle. So the right triangle is here. So it's going to be the magnitude of U over the magnitude of A. So the magnitude of U is going to be A dot B over the magnitude of B. Okay, and then U, the actual vector, should be its magnitude times a unit vector in the direction of U, which you can see is going to be the unit vector of B. So B over the magnitude of B. So this is one thing, and I'm going to use a calculator to get this. And then I also need to find the other vector, but I know that U plus V equals A. So V is going to be A minus U. And I'm going to use a calculator to find that also. So these are, we're going to use a calculator on that. And then I'm just going to keep doing the work here. So let's see how things change. So all I'm going to do is change my picture. Put B here. I'm going to put A here. And then same deal, I think. we're going to say that this is u, and we'll say that this is v. So this is the whole point of practicing, is that you get to the point where you're just like flying through these. This is theta, cosine of theta. First, we use the things we know. So it's a dot b. Oh, not good. Over the magnitude of a, the magnitude of b. That's the vectors that we know. Now we use the right triangle, magnitude of u over the magnitude of b. Okay, and then that means that the magnitude of u for this is going to be a dot b over the magnitude of a. So u, the actual vector, is the magnitude of u times the unit vector in the direction of u, which is a unit vector of a over the magnitude of a. We'll use a calculator on that. And then, so like, I don't know, kind of killing it on this page, maybe, or getting them all wrong. And then a plus v, no, u plus v. What am I doing here? Yeah, u plus v equals b. So v is equal to b minus u. So it's kind of like an afterthought. I feel bad for that vector. It's like you do all the work for the other one. Really, all you care about is the other one. And this one, it's like, oh yeah, also I could find that, however. All right, I'm going to go to the calculator. I'm going to store a and b and just confirm, hopefully confirm all the answers, and then find the ones that we just didn't really do by hand because, you know, what are you going to do? All right, a is 512. B is 724. Okay, so the first question was 3a, which we got. The magnitude of a, which we got. The magnitude of 3a, which we got. A plus b, check. A minus b, check. B minus a, check. All right, doing well. Two unit vectors orthogonal to a. All right, so I guess what I want to do here is the dot product of a and my answers. So my answers were negative 12/13, comma 5/13. This should give me 0 if I got it right. It does. And then the other one was, I mean, like if you switch the direction, it's not going to change. If you switch the direction of one of the vectors in a dot product, it changes the sign. But if the original thing was 0, it's still going to be 0 because 0 doesn't have a sign. So we got both of those right. Angle between. So I need to do the arc cosine of the dot product of a and b over the norm of a and the norm of b. So that, it's kind of like a preference thing. Ooh, so let me get a decimal for that, and then I'll do the arc cosine of 323 over 325. Okay, so equivalent. I don't know why the calculator always like gives that a different answer. So we mentioned at some point that we could do the dot product of the unit vectors. And it might, like maybe this is less typing potentially, like you might prefer it for that reason. Ooh, what? Arc cosine. Oh, I forgot dot product. Jeez. That's what happens. You get dimension errors when you're like trying to. So dot product. Dot p of this. What did I tried to like just multiply them. Strange, man. So this and this. You do the dot product. So maybe this isn't the best way to do it. Either way, you get the same answer. So dot product of the unit vectors. Yeah. So sometimes my brain tells me that that should just be multiplication, as you witnessed. All right, for the next one, now we're doing it. We didn't actually calculate this, so the vector u, so u for this problem, I'm gonna call it u1, is gonna be the norm of u. Oh, okay, so that's gonna be the dot product of a and b over the norm of b, and then I'm gonna multiply that by the unit vector of b. Okay, so that should be u1. Wow. And then v1 should be equal to a minus u1. All right, let me write those down. Those would not have been fun to find by hand, I'm thinking. I think you probably also are thinking that. 2261. I mean, on the other hand, it's just a matter of arithmetic, says the guy who didn't want to do it. Okay, that's that. And then this is 864 over 625 and negative 252 over 625. So like, what can we do to check this? I mean, you can see that U1 plus V1 should be equal to A, which it is. And you can see that the dot product of U1 and V1 should be 0 because they should be orthogonal. And also it should be the case, I mean, that's enough. It should be the case that U1 is a multiple, so like U1 and then B. I don't know, if I do, let's see, what's the easiest way to get that? I think, well, I'll just type 1 over 625. And if I divide that by 7, I should get the same number as if I do 7752 over 625 over 24. Like that's the scalar multiple to show that they're parallel. So it works. And then let's do the next one. So U2 should be the norm of U. So that's going to be, you know, it's really, really similar. Let me just like grab what I did up here. Okay, so it's A dot B over the norm of A. And then we want to turn this into the unit vector of A. Oh, crud. Well, I wanted to call that U2, but it's fine. And then I'm going to call this V1 again, I guess. Should be B minus U1. Okay, so if I add them, I should get B, which I do. And if I dot product them, I should get 0 because they're supposed to be orthogonal. And then if I did, so U and A are scalar multiples. So can I do this? I don't really know. Let me try this. U1 equals A times K. Solve for K. K is 323 over 169. That's actually a really convenient way of doing that. So I didn't need to like type it all in. I just used solve and it found the value of K, which kind of makes sense. I didn't know what it was going to do because what does it do if they're not the same? So like I assume it's going to give me like an error. Let's see, like 1, 3. So there shouldn't be a value of K. False. Yes, there you go. So since it was able to find it, you know that if you multiply A by 323 over 169, you will get U1. That's kind of neat. Anyway, let's go back. Oh, I never wrote those down. Okay, so 1615 over 169, comma, 3876 over 169. And then the other one is negative 432 over 169, comma 180 over 169. All right, so I mean, practice doing those. They're all like really standard types of questions. Like once you get used to them, you just like fly through the process. The thing that will bog you down, or the thing that I am going to accept bogging you down on problems like E and F is arithmetic. You know, like it's really annoying arithmetic almost no matter what you choose, but you can make up whatever problem you want. The rest of them, no problem. So I will stop this here. I'm gonna come back in the next video and keep going. So we got like 2 pages to go in these notes, I think, and we're in pretty good shape, hopefully. So see you in the next one.